The data here shows the yes-no answers to two questions Q1 and Q2 for 66 individuals who are split into two groups, G1 and G2. Initially, we will ignore the separation between the groups and just treat the data set as a whole. We wish to test whether there is an association between the answers to Q2 and the answers to Q1. And for this, we will derive the contingency table using descriptive statistics cross-tabulations. We will choose to put question Q1 to identify the rows and question Q2 to define the columns. Under the output information for cells, we will also request the expected values. We can request a range of statistics. We will click for chi-squared statistics, correlations, phi and Kramer's V, lambda, gamma, Somers D, and Kendall's tau B. We can also select kappa and McNamara and press continue and run the analysis. We can see the contingency table, and this gives us 24 individuals responded no to both question Q1 and Q2. 7 individuals answered yes to Q1 and no to Q2. So this gives our observed counts. The expected counts are also calculated. And we see the results of the chi-squared tests. For the standard Pearson's chi-squared, a p-value of 0.049, suggesting that there is an association. However, we should use the continuity correction in this case because it is only a 2 by 2 matrix, so we use Yates continuity correction, giving a p-value of 0.087, suggesting there is not a significant association. This is also confirmed by Fisher's exact test with a p-value of 0.070. McNamara's test, 0.029, is testing for a difference in the off-diagonal elements, which is suggesting that there is a significant difference between the numbers of people who change from no to yes compared to the number of people who change from yes to no. So there is a significant difference between the values 19 and 7. The analysis also records the various directional measurements, lambda, Goodman and Kuskil's tau, Somers D, and the symmetric measures of phi and Kramer's V. We can also perform this analysis separately for the two different groups, and we will do this by treating them as layers within the analysis. So we take analysis, descriptive statistics, cross-tabulation. Only now we will identify the group as a layer. We press OK, and this table gives us the two contingency tables, one for group 1 and one for group 2. And it also combines the two together to repeat the overall contingency table. If we just look at the data, we can see that for group 1 there is a large difference in the way in which the members of the groups change their minds. So only one person changes from a yes to a no from Q1 to Q2, but 16 people change from a no to a yes in group 1. However, in group 2, the ways in which people change their minds are much more symmetrical. 6 go from yes to no, and 3 from no to yes. This difference between the two groups is shown by the results of the McNamara's test, which tests for differences between the off-diagonal elements. So for group 1, the difference is very significant, but for group 2, the difference is not significant. So this shows that there is a difference between group 1 and 2 in how they change their minds between questions Q1 and Q2.